Students, today let us discuss about conduction and transmission of nerve impulse through a nerve fiber. Here we have a diagram of a nerve fiber. We can see that outside the nerve fiber, extracellular fluid is present and inside the nerve fiber, exoplasm is present. Extracellular fluid and exoplasm both possess positive and negative ions. The extracellular fluid possesses more positive ions than negative ions, hence it is positively charged, whereas exoplasm possesses more negative ions than positive ions, hence it is negatively charged. This difference in charge across the membrane is known as potential difference. The electrical potential difference across the exolemma is also known as resting membrane potential. The extracellular fluid, here we can see presence of positive ions, both sodium and potassium ions are present. In extracellular fluid, the concentration of sodium ions are more than the potassium ions, whereas the exoplasm possesses more potassium ions than sodium ions. Also, we can see that throughout the exolemma, certain voltage-gated channels and sodium-potassium pumps are also present. When a nerve fiber is not conducting any impulse, then it is said that the nerve is at resting stage or it is at polarized stage. When a stimulus of adequate strength is applied to a polarized membrane, the sodium gated channel opens. As a result, influx of sodium ions from the extracellular fluid takes place into the exoplasm. Due to the difference in the concentration of sodium ions across the membrane, as a result, the particular site shows electrical potential difference, that is, outside the plasma membrane, extracellular fluid becomes negatively charged and inside it becomes positively charged. This difference across the membrane is called action potential, and the nerve fiber is said to be at depolarized stage. With the continuous influx of sodium ions inside the axon, the concentration of sodium ions increases. As a result, it leads to the opening of the potassium gated channels. Due to the difference in the concentration across the membrane, potassium ions rushes out into the extracellular fluid. As a result, the concentration of positive ions in the extracellular fluid increases, and inside the exoplasm, the negative ions increases. As a result, the nerve fiber is again polarized. This is known as repolarization. Though The electricity across the membrane has been restored, yet the resting potential is not reached because extracellular fluid now possesses more potassium ions than sodium ions, whereas the exoplasm possesses more sodium ions than potassium ions. This, the resting potential can be reached by the action of sodium potassium pump. The sodium potassium pump is actually sodium potassium ATPase enzyme. It is an enzyme, energy driven action. Three molecules of sodium ions attaches to the binding site which is present in the sodium potassium pump. ATP molecule attaches with the pump. As a result, modification of the structure of sodium potassium pump takes place. As a result, the sodium potassium pump now opens outside, releasing 3 sodium ions into the extracellular fluid. Simultaneously, 2 potassium ions binds to the sodium potassium pump. ATP releases. Changes in the structure of the sodium potassium pump takes place. Thereby, it again opens inside, releasing 2 molecules of potassium ions inside the axon. Hence, a complete resting stage is attained by the nerve fiber. In this way, transmission of nerve impulse takes place across the membrane of a nerve fiber. Thank you.